Hey there, welcome back to another video from the Math Doc. This video will continue with the discussion of equalities and the very basics. We're still working on the various properties of equalities or equations. And in a previous video, which I will link to below, we discussed the addition and subtraction properties of equalities. Here we will discuss the multiplication and division properties of equalities. So similar to that previous video, we will demonstrate what these properties are using pictures of items, sort of really going old school, and and then we'll do some examples and some word examples. So first of all, what is the multiplication property of an equality? Well, you have it up here, and I wrote it in two formats here. On top we have the multiplication with the usual multiplication symbol x, while on the lower bar here I use the dot symbol for the multiplication. And we should be getting used to using the dot more and more, because when we work with variables, we often use the variable x, and then it can get a little bit confusing when we have both multiplication and x. So I will try throughout this video to use this multiplication symbol, the dot, but I will try to remind you as we go along that that's what we're doing, in case this is sort of new. So what is the multiplication property of an equality? Here it is. If A equals B, so that's our initial equality, A equals B, then A times C, okay, right here, equals B times C. So just like in the other properties, what we have to be sure we're doing is that we are multiplying both sides of the equation by the same number, which here is signified by C. And the same thing goes on for this lower bar here. If A equals B, then A times C equals B times C. And our demonstration here is with bunnies. And you know what they say about bunnies, that they have lots and lots and lots of bunny babies. And so in this case, we took two bunnies. We had two mom bunnies. So we can say the bunnies equal 2, right? Because we have two of them. Now we say, oh, each bunny had 3 babies. So we multiplied the number of bunnies by the number of babies they each had in order to get the total number of babies. So how many babies do we have? We have 1, 2, 3, 4, 5, 6 babies, right? 3 from the first and 3 from the second, so that's just 2 times 3. So we have 6 of these babies. On the other hand, if we want this equality to hold, if I am allowed to bring the equal sign down here, I have to multiply my number here also by 3. And so by multiplying by 3, 2 times 3, or with the dot symbol 2 times 3, I'm keeping this equality, because by having 3 babies each, I multiplied the number. The baby number is just 3 times the number of the moms, and 2 times 3 is just 6. And indeed we said we had 1, 2, 3, 4, 5, 6 babies. So that is a demonstration of how we use the multiplication property of an equality. And what about division? Well, division is the inverse property of the multiplication, right? It's the inverse operation as well. So if A equals B here, then if we divide both sides of the equality by the same number, right, by C, we will be able to keep our equality. So if A equals B, then A divided by C equals B divided by C. And again, our demonstration is with items. So we have 4 cupcakes here. Okay, so 4 cupcakes. So the cupcakes equal 4. Now let's divide the cupcakes to 2. So say we have two siblings, and they each get half of the cupcake, so we're going to divide it into 2, and we remain with, on each side, just 2 cupcakes. So the result of dividing the cupcakes among the 2 siblings is that each one gets 2 cupcakes. So I'll attempt to draw that sort of. So the result of the division is basically 2 groups of 2 cupcakes. So the answer here is 2, right? Now, in order to keep this equality here, we will have to divide this side of the equation by 2 as well. And so we get 4 divided by 2 here on the right. So we have 2 cupcakes now on the left, right, because we divided by 2, equals 4 divided by 2, which is just 2. So again, we got the correct answer here by using this property, the property of division. In the next slide, we will look at some examples that'll help you sort of understand how to apply these 2 properties, and then we'll go on to some word problems. So these problems will just illustrate how to use the 2 properties. And in this slide already, I've removed the bar that showed the multiplication with an x because I want us to get used to that, especially because we are using a variable x. And very similar to the addition and subtraction properties, what we're trying to do when we have a variable is isolate that variable, because if we have the x isolated from the numbers, we know what x is equal to. So we can basically solve our equation and find what x is. So let's look at our first problem here. X over 2, right? X divided by 2 equals 6. So here I'm using the fraction way of writing division, right? So we have x halves, which is also x divided by 2 equals 6. Now we would like to isolate our variable x here, but we have this division by 2. So what we're going to do is we're going to multiply both sides of this equation by 2. And let's see what we get. So on the left-hand side, we have x halves, right, times 2. I'm leaving that little x here still, equals 6 times 2. Now on the left here, we have 2 up here, and we also have the half. 2 times a half is just 1, right? These 2 cancel, and we remain with x equals 6 times 2 is just 12. That is our solution. And as always, we like to check to make sure we got the right answer. Let's insert this solution x equals 12 in our original equation here. So we had x divided by 2, x halves, that's 12 halves, equals 6. Okay, what are 12 halves? Well, 12 halves are exactly 6 wholes, right? There are 2 halves in each whole, and so we have 6 equals 6, and that is correct. Okay, let's move on to our second example here. Here we have 3 times x, and I used the dot as the multiplication sign. 3 times x equals 15. Again, we would like to isolate the x. This time it is being multiplied by a whole number. Let's try and divide both sides of this equation by that number by 3. So divide by 3. What do we get? We get 3 times x divide by 3 equals 15 divided by 3. So on the left-hand side here, we have 3x divided by 3. 3 divided by 3, we can change the order of operations, right? We have x times 3 divided by 3, and 3 divided by 3 is just 1. So we get x equals 15 divided by 3, which is just 5, right? X equals 5. And we can check that if we put 5 back into our original quality, and I don't even have to write this out. We have 3 times 5, which is just 15, and 15 equals 15. I do want to use this example to write and show you what the standard form of writing a division of a formula is. So if we have 3 times x, and when I say formula, I mean an equation. 3 times x equals 15, and we want to divide both sides by 3. All we have to do is use the fraction symbol and put the 3 in the denominator, because by doing that, we basically have divided now both sides by 3. We have on the right hand side 15 divided by 3, which is just 5. I'm writing the equality sign downwards here, and in a vertical. And the same thing here. Here the 3 in the numerator and the 3 in the denominator cancel, and we get x. And so we have x equals 5. Okay, and this is shorthand for basically writing a full division symbol over there. Okay, our third example here is x over 3, so x thirds equals 3. Again, we have a fraction here, so our inclination in order to isolate the variable x is to multiply by 3. Let's do that. Let's multiply both sides by 3. So we have x thirds times 3, and I'm using again the dot, equals 3 times 3, right? On the left-hand side, these 3's cancel. We have x equals 3 times 3 is 9. And again, let's check our result. We'll insert x equals 9 into our first equation. That's 9 divided by 3, or 9 thirds equals 3. And we know that this is correct because 9 thirds is just 3. 3 equals 3, and that is correct. So finally, we have one more of these simple examples, and then we'll go on to some word problems. We have here 5 times x. We've used the dot for our multiplication symbol. 5 times x equals 15. And this time, we're going to want to divide by 5, right, in order to isolate our variable x. So we write 5 times x divided by 5 equals 15 divided by 5. So again, we divide both sides by the same number. Here our two 5's cancel, so we're left with x equals 15 divided by 5 is 3, right? So 15 fifths are just 3, and x equals 3. And again, we can easily check this by inserting our solution. 5 times 3 equals 15, and indeed 15 equals 15. Perfect. So these were our simple examples of how to use the multiplication and division properties. And we will go on now to solving a couple of simple word problems that will show you how useful these properties are. So in our first example here, the first word problem, I want to remind you what we're going to do is we're going to take the word problem, we are going to build an equation, and then we are going to isolate the variable. So we have two steps. We first build the equation, and then we isolate the variable in order to solve for that variable. So here's the problem. Jonathan owns a team of robots, each having 6 grabber arms. Okay, 1, 2, 3, 4, 5, 6. In total, the team of robots can grab 24 items at once. How many robots does he have? Okay, so let's again highlight what we actually know. So Jonathan owns these robots, and each has 6 grabber arms. In total, the team can grab 24 items at once. That basically means that the team has 24 grabbing arms. The question is, how many robots does he have? So this is our x, right? Number of robots. Okay, so what do we know? We know that he has X robots. Each robot has 6 grabber arms, right? So in total, we have X times 6 grabber arms, right? Each robot has 6, and we're multiplying the number of robots by the number of arms. In total, we saw that we have 24 arms. So this is our first step. We actually wrote out our word problem as a mathematical expression, as a mathematical sentence with an equality sign. So now we have an equation, and we have to solve for our number x. So how do we do that? Well, we have x multiplied by 6, and so we probably want to divide both sides of this equality by 6. Let's see how that works. Well, we have x times 6 equals 24. Let's divide both sides by 6, and I'm using the shorthand of using a fraction symbol, right? And on the left-hand side, the 2 6's, the top and bottom of the fraction, are canceled, so we're left with x. And on the right-hand side, we have 24 sixths, which are just 4, right? So if we do 4 times 6, we get 24. So this is the result. So what does this mean? It means Jonathan has 4 robots. Okay, and that is our solution. And we can check it. We can say if we have 4 robots, we multiply that by 6, and we get 24. So 4 times 6 equals 24. And we are correct. So this wasn't too bad. We did both the building of the equation and the solving of it and getting the results. So our final word example for this video has to do with cupcakes. And again, we're going to try to focus on using the multiplication symbol of a dot. So Naomi's mom baked 18 cupcakes for her birthday. So I already know one number here, which is the 18. If each of the kids got 3, so each kid got 3, that's another number. How many kids were at the party? Okay, so let's try to first build our equation, right? Our first step is building the equation, and later we will isolate our variable. What is our variable? Our variable is how many kids, right? Comes from is the answer to how many kids were at the party. So x is the number of kids. Okay. So now let's see. So we had 18 cupcakes, right? We started with 18 cupcakes, and we divided them by to all the kids. So we divided them by the number of kids, which we said is our variable x. 18 divided by x. And we said that each one got 3, right? So this now is our equation. This is our story, and I'll repeat it again because now this one might be a little bit more confusing because we're dividing by our variable, and we haven't seen that till now. So we have 18 cupcakes. We had x kids. We divided all the cupcakes among the kids. So we divided 18 cupcakes by x kids, and each kid got 3. So that is our result. Now, how do we solve for this? We will isolate our variable x, right? And by that way, we'll see what x is equal to. So we have 18 divided by x equals 3. So let's write it. We can write it also in this way. 18 divided by x as a fraction equals 3. In both cases, what do we have to do? It looks like we would like to multiply by x, right? So let's multiply both sides of this equation by x. We have 18 over x times x equals 3 times x. Now, just like for a regular number, when we have a variable in the numerator and in the denominator, we can cancel them, right? Because they are equal. X divided by x is just 1. So we get 18 on this side and 3 times x on this. But we're not done. Note that our x is still not isolated. We have this 3 here. So let's take a second step and divide now both sides by 3. We'll divide this side by 3 and this side by 3, right? And we keep the equality because we were careful to divide by the same number. So on the right-hand side, we get x, right, because the 2 3's cancel. And on the left-hand side, we have 18 thirds, or just 18 divided by 3. And that is 6, right? 6 times 3 is just 18. So we get 6. So the number of kids in the party was 6. There were 6 kids in the party. So this is the end of our video on the multiplication and division properties of equalities or equations. Thanks for joining me again. If you're new to this channel, please subscribe. And if you have any questions, please include those in the comments below. We will follow up with another video where we start combining the different properties and we go into multi-step solution. But we will do that slowly and hope to see you at the next video. Thanks. Bye-bye.